I didn't get a chance to finish this very last question, which is on the squeeze theorem. I have a silly story about the squeeze theorem. Do you guys want to hear it? So when I was in Calc 2, I had my roommate from college. We were both freshmen, and we were in Calc 2 together. And we were like the only freshmen in there. We felt really awkward at times. And our teacher said something like, does anybody know what theorem we should use here? And my roommate in college raised her hand. And she's the sweetest girl ever, but she has the thickest Kentucky accent you've ever heard in your life. She was raised near Louisville, as she would say. And she goes, you use the squeeze theorem, but she said it like this. Squeeze theorem. And the professor looked at her and he goes, what was that? What theorem do you use? And she said it again. She goes, the squeeze theorem. And he goes, no, actually, we use the squeeze theorem. And she was like, so I was dying laughing at that. So every time I see the squeeze theorem, I think of that. But it's also called the sandwich theorem. So basically the theorem says if you have a function g of x that's between two other functions, f of x and h of x, as long as you're close to the x value, as long as you're close to the x value, then as long as you take the limit for both of those functions above and below, you take the limit for both of them, and as you get closer to the x value of a, their limit goes to L. So do you guys see how this works? So the above function, the below function, their limit as you get closer to a, they both go to L. Then what has to happen? Then the limit as x approaches a of our g of x function, the one that was in the middle, has to equal L as well, because it's squeezed or sandwiched between the other two functions. So we use this for several functions. We can use it for lots of different things, but the ones that you guys will mostly see are sine and cosine. Okay, and we were mentioning this yesterday. So sine of any x, so even of 5x, the most that sine of any angle can be is 1. Okay, so think about your unit circle. The biggest y value you have is 1. The smallest y value you have is negative 1. Does that make sense? So in other words, this function that we have is squeezed between 1 and negative 1. But what is our function? It's x squared times sine of 5x. Okay, so what we're going to do is we're going to multiply by x squared on each of these. And we have an inequality, and we know that if we have inequalities and we multiply by a negative, we have to flip all the signs. How do I know for sure that this is not a negative number? Anything squared is positive, right? So if I'm multiplying through by x squared, it's automatically positive. So I can keep my inequality signs the same way. So I can do negative x squared, and then x squared times sine of 5x, and then is less than or equal to x squared. Okay, so the function that we had originally now is squeezed between two things. So let's think about what negative x squared and positive x squared looks like. Here's positive x squared. Here's negative x squared. What is the limit as x goes to 0 for positive x squared? As you get closer to 0, what y value? Yeah, it's 0, right. What is the limit as x goes to 0 for negative x squared? Same thing, right? 0. So any function that is squeezed between those, right, as you get closer and closer to 0, their limit will also go to 0. Well, this function is between those. And if you look at what the graph looks like, maybe I'll pull up Desmos to do this one. Let's graph this x squared sine of 5x. It's kind of cool, because anytime you have that sign, it oscillates. Look at that. Isn't that cool? So let's do a new one. Do you see how it's squeezed between? Let's do another one. Squeezed between. So if you zoom in here, as you get closer and closer to 0, this function, the red function, is squeezed between the other two functions, so their limits all go to 0. Does that make sense? Do you guys get it? So we're going to say here, therefore, this means therefore, do you guys know the 3 dots? Therefore, the limit as x goes to 0 of x squared sine of 5x equals 0 by the squeeze theorem. Or you can say sandwich. Okay, and that was because those other two limits also went to 0. Does that make sense? Do you guys get it? Okay, so you could have lots of different functions there. All right, so let's stop there.